Bang namoy! Okay, well, it is a Lunar New Year, more or less, okay? Depending on when and where you're watching this. So we'll continue with our discussion on matrices and inverses for section 8.3. And this part is going to teach you some other cool ways to solve for linear systems using inverse matrices. Hopefully you can do that on your calculator. Hopefully you know how to do that in your TI Inspires, okay? Alright, let's get to it, okay? I'll be quick, okay? Hang in there with me. First of all, I have this linear system here. It's number 44 from your textbook, depending on whatever you're using. And it's x minus 2y equals 0, 2x minus 3y equals 3. And obviously, our goal is to solve for x and y, okay? Now, as you recall from the previous sections, you remember matrix A, matrix X equals matrix B, okay? And remember, we can also do this. We can't divide matrices because it doesn't fall into our properties, but we can multiply by the inverse to each side. But remember, it's left side, so we got to multiply the left side inverse here. Okay, remember, it always has to follow the order, okay? And it's not, always, if it's left side here, okay? And then that means this becomes the identity matrix, right? Identity matrix, and this is x equals A inverse B, which means x is equal to A inverse B, which is going to give us our nice x and y value. This x does not mean this x is a matrix, okay? All right, let's keep that in mind. Let's actually set it up. Let's set up our coefficient matrix of 1, 2, negative 2, negative 3. If I'm speaking too quickly for you, make sure you slow down your pace on your YouTube, okay? XY, right? That's your XY, that's your A, X, and let's do our B, which is our constants here, 0, 3. And that's our 2 by 1 B matrix, all right? Now, I have to first calculate my inverse, because I need my inverse to be multiplied to both sides. So I'm going to go on the side here and calculate my inverse. And you remember how to calculate your inverse? You calculate your inverse by doing, so A inverse is equal to 1 over, right, AD minus BC, and then you got to switch your variables. Remember that? So it's going to be negative 3, 1, 2, and negative 2. Do you remember that, you guys? Finding the determinant, basically. All right, let's do this. So it's AD minus BC. So in our case, our AD is AD, so it's a negative 3. BC, which is negative 4, so plus 4. And then we got to do negative 3. We inverted the A and the D, and then we changed the signs. Sorry about that. We changed the signs for B and C. Okay, that's from the previous section, so make sure you look over that. Okay, and then voila, this is just positive 1. So our A inverse is simply negative 3, negative 2, 2, and 1. Okay, if you have your calculator handy, you can check this too. Just type in this coefficient matrix and put a little -1, the superscript of negative 1, and it'll calculate the inverse for you. Here's your inverse. So what you're going to do is you're going to multiply the inverse. A inverse goes here, negative 3, negative 2, 2, positive 1. When I multiply 1, 2, negative 2, negative 3, which is the coefficient matrix, and then I have my xy here, and I have to apply the inverse here too. Uh-oh, I'm running out of room here. So it's 0, 3. So again, A inverse, and this is my B. This is my A inverse, this is my A, and this is my X. When I calculate that, this better give me a identity matrix. Let's check, okay? Negative 3, 4. Negative 3, 4, that's positive 1. Dun, 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 dun. Oh, sorry. Dun, 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 dun. Play music, okay? Negative 3, positive 4, positive 1. 6, negative 6, 0, 1, 0. Negative 2, positive 2, 0, 4, negative 3, 1. That's an identity matrix. So that means this all just becomes identity matrix. Capiche? It's gone, okay? So you're left with xy, which is equal to this product here, which becomes, I'll do the calculation for you, 0, 6, which is 6. Negative 2 times 0 is 0. 1 times 3 is 3. So your answer is 3. So 6, 3 is your solution. Of course, you can do that using Gaussian elimination. Remember this? With Gaussian, Jordan, and so forth. You remember this? Augmented matrix. But you can also do it this way. Whatever technique you like better, okay? I actually like this way. I think it's quicker, finding the inverse rather than doing the whole Gaussian, Jordan, okay? All right, let's try another one. And please check using your calculator, okay? All right, let's move on to the next question. Now, this question is a little bit cool. Number 48 in your textbook. It has 3 unknowns and 3 equations, so you know you have a 3×4 matrix if it's augmented. But they gave you the inverse matrix. Yay! So what you're going to essentially do is you're going to apply the inverse, and you have an A inverse AX equals A inverse B. You're going to actually do that since it's given that already. So that means your X is going to equal A inverse, which is given to you here. Okay? A inverse, and you have your B here. What's your B? It's your constants, right? -1, 2, 0. Your 3×1 constant, okay? If you need to write this out better so you can see it more clearly, go for it. But this is the A inverse because it follows this rule here, okay? Remember, your A is your coefficient matrix, your X is basically your variables, and your B is the constant matrix. Okay, so it follows that rule here. So when you do that, go ahead and quickly do that. What did you guys get? Hopefully you got something like 1, 7, -9, which tells me that when I plug it in here, it should work. Let's check. 1 plus 7 is 8, minus 9 is -1. Checky, and check for all 3, and it should be the solution. Now, if you want me to do the calculation with you, I can do that with you. Ready? -1. 2 plus 2 is positive 2. Positive 2 plus 0 is, -1. Positive 2 plus -1 is positive 1. Plus 0 is positive 1. Let's check it again. 3, 4, that's 7, 0, that's 7. -3, -6, 0. -3, -6, 0, that's -9. And if you want to write it out, you can go -3. 3 times -1 plus -3 times positive 2 plus 0. Ding, ding, ding. Okay? And then you get -1, 7, -9 is your solution. All right, let's move right along to part 4. Part 4. Now, these matrices are singular. Let's try. What does singular mean? Again, I think this is a review. Singular means what? Singular means no inverse. Think about it. Single. Okay, it means nobody or no inverse in this case. Okay? And non-singular, it means you can have an inverse. Has inverse. I know it's a little bit weird, right? Because no sounds like non-singular, but think of it this way. No inverse! You're single. Okay? Like nobody loves you. Singular, okay? Find the inverse of given matrices, and you have. So basically, we're going to show, we have these 2 matrices here, a 2×2 and a 3×3. Notice these are both square matrices, because only square matrices can be singular or singular, right? Or non-singular, sorry about that. All right, so let's try this, but we're going to try this using our good old reduced row echelon way. Find the inverse of given matrix. So if we could find an inverse, that means if we can find the inverse, and we have this form. Do you remember this? We have A, and then we have this. We're going to have to switch it to the identity matrix on the left side, and then our inverse goes here. Now, if this cannot be done, then you know it's a singular matrix. If it can be done, you know for sure that it does have an inverse. So it's non-singular, okay? Let's try that really quickly. So we have 3, 1, 6, 2, ... Our identity matrix goes here. Now we're going to swap those rows, obviously. We get 1, 2, ding, 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 0, 1, ding, 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 3, 6, 1, 0. Now with a little bit of RREF, dun, 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 dun. Okay, so I'm going to multiply this guy by -3, add it to here. Let's see what happens. I'm not going to show all the steps, but I'll show you some steps. -3, 1, 2, ding, 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 0, 1, -3, 3 is 0, -6 is 0, 0, 1, so it's 1, -3, and 0, so it's -3. Okay. Now, wait a minute. Okay, so you remember where our goal is. We're trying to get this to be, identity. But wait, this is already a 0 here. We can't possibly make that a 1, right? So we can conclude. Therefore, we can conclude this is a singular matrix. If there's no way that we can make this left side become an identity matrix, it's a singular matrix. That means this guy does not This guy does not have a inverse, okay? Let's go to this side, okay? So we're going to prove that this guy, 3, 1, 3, 1, 0, 2, 0, 1, 1, negative 1, 2, ding, 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 1, 0, 0, 0, 1, 0, 0, 0, 1. And we're going to swap them, okay? Here's the identity. We're trying to get the identity to be on the left side, and A inverse will appear here. Now, I do this magic called RREF. If you want, you can do it by hand, or you can use a calculator. And here's what I ended up with. In the calculator, it gave me this. 0, 1, 0, negative 1, 2, 0, dot, 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 0, 0, 1, 1, 0, 3, and 0, 1, negative 2. Okay? Oh, sorry, negative 3 here. Try that on your calculator. Just RREF this sucker. Don't forget your parentheses around it, okay? Now, what about here? So it looks like, again, it's going to be impossible for us to make into an identity matrix here because of the 0, 0, 0. So again, it's also singular matrix. And I believe if you actually put this into your calculator and do like a B inverse, so enter this into your calculator and put a little negative 1 here, if it tries to calculate it, what it'll tell you is it'll tell you that it's singular, okay? All right, good luck everyone! Please like and subscribe. Okay, bye!